All right, this question here, it's helpful to know there's a point that I make when I teach it in class, and I think it's in the book somewhere, but just so you know, every exponential function, so if it's, say, f of x equals a to the x, every exponential function, unless it's been shifted, unless there's some number added to it, or like this -4 is going to be a shift, but if you just have some number to x, it will go through, if x is 0, then you get 1, right? Regardless of the base. So if you have 527 to the 0, you get 1. Alright, if x is 1, then you get a, because a to the 1 is just 1. And then if you put in -1, you get 1 over a, right? Because a negative exponent says flip it over and then put it down in the denominator with a positive exponent. So these 3 points on every exponential function. So when you're talking about a logarithmic function, let's say f of x equals log base b of x, then you have the inverse of those 3 things, right? 1, 0, right? This is an inverse function, so the relationship between x and y swaps, right? So if you take the log of some base b of 1, it's saying what power do I raise this base to get 1? I raise it to the 0 power. Likewise, now I'm using a different letter here, b, just to be clear, that there's that can be any base. It don't have to be the same base a. So log base b of b is what power do I raise b to get b? I raise it to the 1 power. And then likewise 1 over b gives me -1. I tell you all that just to tell you that first off, that the graph should kind of go through those points, and then when it doesn't, that means it's been shifted. Alright, so ln of x should go through those same points. It should go through 1, 0, and instead of the base being e, it's the little magic number, I guess we'll call it e, and then 1 over e and -1 should be my points. Alright, now the first question here says find the domain of f. The domain of f always has to be greater than 0, right? So when you take any logarithmic function, the thing that you put into it has to be greater than 0, because the inverse function is the exponential function. There's no way to make this equal 0. There's no value of x that will make this equal 0. Alright, so now we're going to choose our graph. So here's where we'll use our points. Alright, we should go through 1, 0, but we have a -4 here in front, and that indicates a vertical shift down 4. So instead of going through 1, 0, we need to look for something that goes through 1, -4, and something that goes through e, which is about 2.7, and -3, and something that goes through 1 over e, which is about 0.3, and -5. Alright, so we're looking for a graph that does that, or one that's basically been shifted down. And every exponential function goes through, logarithmic function has a vertical asymptote right through the y-axis. Unless it's been shifted left or right, it'll be right there. For example, this graph has been shifted to the right, and so it has some horizontal shift going on. But anyway, that's the graph because it's been shifted down. And so the range for any logarithmic graph is always -infinity to infinity, and the vertical asymptote is at x equals 0 because there's no horizontal shift, right? If there is some horizontal shift, then that asymptote can move. All right. To find f inverse, you have to do this math here. Let me write out the steps and I'll show you. So you start out with -4 plus ln of x equals y, and then you swap the relationship between x and y. And then once you do that, you solve for y. So we have ln of y equals x plus 4, and now we'll raise both sides to the e to get rid of that ln. And so this one's domain, you can put anything in here for x, and notice that the range of this function and the domain of this function are matched. And so then for the graph, we shift everything to the left 4, and therefore we get graph A.